welcome to BioLogic Science News. If you're at all interested in outer space and alien life, chances are you've heard about the amazing discovery in the TRAPPIST-1 star system. It's an ultra-cool dwarf star, 40 light-years away from Earth. This star is really small, possessing only 8% the mass of our Sun, and it's not very hot, relatively speaking. TRAPPIST-1 burns at around 2300 degrees Celsius, or more than 4100 degrees Fahrenheit. This is pretty hot by human standards, as it's around the same temperature as the maximum operating range on an industrial furnace. But from a cosmic perspective, the dwarf star is literally ultra cool. It's half as hot as our Sun, and less than 0.1% as bright. If this star replaced our own, the Earth would freeze overnight. Virtually everything on land and most or all of the stuff in the oceans would perish. The habitable zone for this star is very small, because it's so dim and so cold. Any planets in the habitable zone have to be in extreme proximity, closer than Mercury orbits our Sun. As it happens, the TRAPPIST-1 system has 7 planets. 7 terrestrial planets, roughly the size of Earth. This is an amazing find, as no other known star system has so many terrestrial planets. For that matter, no other known star system has as many terrestrial planets in the habitable zone. These planets, from nearest the star to those that orbit farthest out, are called planets B, C, D, E, F, G, and H. The innermost planet has 1.5 days in its year. The outermost planet completes an orbit in less than 19 days. The planets E, F, and G orbit within the habitable zone of the star, in the area where it's just warm enough for liquid water. The outer planets are too cold, likely covered in ice or barren minerals. The inner planets are too hot, most likely wrapped in a Venus-like atmosphere. Only the 4th, 5th, and 6th planets orbit just far enough away to possibly hold liquid water, and where there's water, there might be life. Because of their sheer proximity to their star, scientists think it's most likely that all the planets are tidally locked. This is unfavorable for life, as planets that are tidally locked experience temperature extremes. The sun-facing side is heated by the perpetual glare of the star, while the dark side endures an eternal night. If the planets have an atmosphere, the temperature differences will cause hugely powerful winds to sweep across the surface. On tidally locked planets, there exists a thin region, like a belt, separating the hot and cold sides. This region is the terminator line, and it exists in a perpetual twilight. It's a land with a never-ending sunset. In this thin region, away from the direct glare of the sun, but still within its sight, so still receiving light energy, life might be able to find a temperate spot to grow and thrive. It's unlikely, and made less so by the torrential winds, but it's definitely possible. The fact that the planets orbit so close together supports several interesting ideas. First, any asteroid impacts on one planet would shower the others with debris, which means that panspermia is much more likely. Life clinging to a little rock that gets thrown from one planet to the other. Second, their proximity means that they exert a gravitational influence on one another. As the planets orbit and pass each other, their gravity signatures cause each to tug and distort. Much like the moons of Jupiter, these gravitational interactions could induce tidal heating. The moons could be flexed and distorted, generating heat that could sustain life. It's even possible that these gravitational interactions could interfere with a tidal lock, wobbling the planets and giving them a strange, pseudo-night and day cycle. This could also heat the interior of the planets into a liquid magma core, which would give each world a protective magnetic field. Any such field would offer the planet some degree of protection from the dwarf star's X-rays and ultraviolet radiation, shielding any life that happened to be growing on the surface. Like the moons Europa and Enceladus, tidal heating could make life possible in an ocean covered by a planet-spanning sheet of ice. The outer planets of the TRAPPIST-1 system could have massive oceans, teeming with alien plants and fish beneath their icy crusts, assuming they get enough heat energy from the gravitational interactions. Liquid water oceans could possibly hold alien ecosystems on the planets of the habitable zone, and depending on their atmospheres, the land could be covered in grass and soils and plants, just like the Earth. All the planets in the habitable zone are around Earth size, or slightly smaller, so it's entirely possible. Anything is possible, really. That's why it's so exciting when astronomers find something like this. It fuels the fires of the imagination when we see other worlds ripe for life, in the range where liquid water could possibly exist, with atmospheres that just might be conducive for life. The James Webb Space Telescope is going to be looking at the TRAPPIST-1 system to study the atmospheres of the planets, which will give us a much better idea of the prospects for life on these alien worlds.